Hi, everyone. Welcome to class. Today we're going to be doing a new lesson, and I'm recording it from our classroom. So follow along with your notes as I go through and I share this with you. Our topic today is we're going to title our notes Factor when a does not equal 1. We're going to be talking more about factoring polynomials, and we're going to discover a method for factoring when the leading coefficient is something that's not 1. When it's 1, great, we get to use the strategies we've already talked about. But if it's not equal to 1, then there's a different way for us to solve it. Let me show you what I mean. Here's an example that we'll call number 1. We're going to use 6x squared plus 23x plus 7. So the reason we need a new method is if you try to factor this the way it is now, you'd be trying to think of, okay, what numbers can add to make 23 but multiply to make 7? And there aren't any that are going to work. But then you might notice that, oh, there's a 6 out here in front of the x. So if you were to draw a table, that's going to end up changing some of those numbers inside, and you're ending up with just a whole bunch of possibilities. So instead, I'm going to show you a method for solving it. And wouldn't it be great, this is the way I like to think about it, wouldn't it be great if this number in the middle was not a 23, right? What if it was something that like more easily matched the 7? And so what we're going to do is we're actually going to end up breaking this apart and creating something new there without changing the structure of the problem. And so it's going to look like this. Instead of 23x here, I'm going to make my own number. I'm actually going to make two numbers that add to make 23. And when I do that, I'm going to think of this. I'm going to think of multiplying what we call the a and the c term. So in a polynomial like this, we call the coefficient over here a in front of the x squared. Whatever is in front of the x, we call b. And whatever is on the end, we call a c. And so what I'm going to do is I'm going to multiply my a and my c together. And I'll show you what happens, like why we want to do that once we do it here. So 7 times 6 is going to give me 42. So a times c is 42. And now what I would do is I would think of, okay, what are the factors of 42 that add to make 7? Sorry, that add to make 23. See, I'm already getting confused. We already used the a and the c. So now what we want to do is we want to find which ones add to make 40, or sum to make the b. There we go. So let's see, factors of 42. I'm thinking maybe a 2 and a 21. That would make 42. Ooh, and those add to make 23. Interesting, cool. So I'm going to use this then in my problem here. I'm going to keep my 6x squared. And now I'm going to use the first factor here, the 2. So I'm going to add 2. And what I'm doing is I'm breaking apart the 23x. So I'm going to keep the x on here. And then I'm going to write this next one, which is positive. So it's plus 21x. And then I'm going to put my 7 on the end here. Okay. So that was a long, kind of complicated way of going about and breaking apart this b term. But look, we haven't broken any rules of algebra yet. We're still following, we're still keeping this expression the same as it was before, because we went backwards, we put these back together, we get right back to 23. So we haven't made any mistakes yet. Now, the next thing I want to do is I want to treat the beginning and the end of this problem separately. I'm looking at these two as kind of separate pieces of the expression. And in this first piece, I want to think, is there any common factor that I can divide out of these? And notice they both have even numbers here, so I can divide out a 2, but I can also divide out an x. So I'm going to divide out a 2x from both of these, and let me figure out what I would have left. If I divided 6 by 2, I'd have 3. And if I took out one of the x's, then there must be one there. And notice if I multiplied those, I'd get 6x squared. So I'd move right back where I was. Good. If I divide out 2x here, then what I'm left with is just a 1. Okay, so I broke this into these two kind of factors. And now I bring down my plus, and I do the same thing over here. Is there some number that divides evenly into both of these? I see a 7. would divide evenly. The x wouldn't though, because this doesn't have an x. So in this case, my common factor is just a 7 and it's positive. And then let's see what's left after I divide it. 21 divided by 7 is 3 and my x is still there. 7 divided by 7 is 1. And so a 1 is there. Now, this is a great spot to stop and check your work. Notice the numbers inside the parentheses here are the same. It means, yay, no mistakes. No mistakes yet. If we went through all this and we ended up with numbers inside here that were different, polynomial inside there that was different, then it means we made a mistake somewhere and we have to go back and start again. Okay, now this next part can get a little bit tricky. What I'm trying to do is I'm trying to create the multiplication. I'm trying to factor this into the multiplication, right? Into what was used to make it. And so I know they used a 3x plus 1. And so even though it's there twice, I'm only going to write it once, like this. And then in my other binomial, I'm going to take the term over here and the term here. I'm going to put them together. So I get 2x plus 7. This is my answer. If you multiply those, you get to what we started with. Isn't that crazy the way that works? By doing this a times c and finding the factors that add to 23 and then breaking apart the problem and following this pattern, you end up with these factors. And we could even check our work. If I was going to check, I might do like FOIL. So I'd have 3x times 2x, and then I do 3x times 7, and then I do 1 times 2x, and then I would do 1 times 7. And if I combine all those, let's see, I get 6x squared, I get 21x, I get 2x, and I get 7. And then we put those all together, and we get 6x squared plus 23x plus 7. Hey, look, it worked. See? So this is what these are the steps you have to go through when you end up with an A term out there in front. So it's kind of a lot of work and it doesn't feel so good all the time. But the nice thing is, you know, when you have to do it, you have to do it when there's a number in front of the x squared, when you have a coefficient, okay? I'm going to give you one for you to try on your own. And it's going to look like this. I'd like you to try 6x squared plus 13x plus 5. Remember, you're going to go a times c, and then you're going to find the factors of that add up to your b term, okay? Pause the video here and give that a shot, and then when you restart the video, I'll show this worked out, okay? Pause now. All right, we are going to go through the answers for this one. So when I multiply my a and my c, I get 30 because it's 6 times 5. And so I'm looking for the factors of 30 that add to 13. Let's see, it might be 2 and 15 make 30. Ooh, and if this was negative, they would add to 13, but they wouldn't make the 30. Okay, so 2 and 15 don't work. Maybe 6 and 5. 6 times 5 is 30. But then if you add those 11 now, maybe a 3 and a 10. Oh, there it goes. 3 and a 10 add to 13. So I want to use a 3 and a 10. I want to break this apart. And it doesn't matter which one goes first, which is a cool part of this process. So I get 6x squared plus 3x plus 10x plus 5. And then you look and you treat these separately. You divide out the common factor. So we get 3x. This would be 2x plus 1. And then over here, we would divide out a 5, and we get 2x plus 1. There's my first check. I know I'm on the right track. And so then for my answer, I have the 2x plus 1, and the other part is the 3x plus 5. There we go. There's your answer to that problem. All right. We are going to try some more. Ooh, I'm running out of room here quickly. I think I'm going to flip my paper over for the next one. This will be number 3. Yep, number 3. All right, so let's say we had, trying to find a good one. Oh, here's a good one for us. Let's say we had 3x squared plus 4x minus 15. So again, I know I'm going to have to use this method because I have a coefficient in front of the x squared that's not a 1. So when I go a times c, I'm going 3 times negative 15. So that gives me negative 45. The one that's different about this example than the others was now we're dealing with some negatives here. All right, and so we want them to sum to be our b term, which would be 4. So let's see what sums to make 4. This might be maybe divided by 5, maybe like 5 and 9 would make 45. But let's see, this would have to be negative. It'd be negative 45. Ooh, and if we add them, we make 4. There we go. So I'm using negative 5 and 9. So same kind of thing as before. I'm going to break apart the middle term. We're going to go 3x squared minus 5x. Again, it doesn't matter which one comes first. Plus 9x minus 15. Losing a little focus there. There we go. And now kind of the same things as before. I noticed the only thing I divide out of this first half is an x. So I'm going to go ahead and take that out then. So I have x parentheses 3x minus 5. And then over here, it looks like I divide out a 3. And it's positive 3. So see, we get 3x minus 5. Ooh, there's my check. I'm on the right track. Those two polynomials match. So 3x minus 5 is one of my terms. And the other one is an x plus 3. There we go. So negative works the same way. You just have to be careful when you're coming up with your factors that you account for that. Okay? So let me give you another one to try on your own. I would like you to try, we'll go with some larger numbers. 10x squared plus 31x minus 14. Go ahead and pause the video now. And then when you're ready, you can resume and I will show you this worked out. All right, go ahead and pause. Well, here we go. This one took a lot longer, at least for me. I don't know about for you. I actually ended up having to erase some of my work and going back through the factors again. So when we multiply the a and the c, we get negative 140. And then we want them to add to make 31. So I just reworked this and I started with 1, just working my way up with the factors. And when I got to the negative 4, I noticed negative 4 times 35 would make that. And if we add them, we get 31. So I'm going to break this apart. We get 10x squared minus 4x plus 35x minus 14. And I'm going to treat the first half and the second half separately. Over here, let's see, we can divide out a 2x. And so then we have 5x minus 2 plus, over here I have a minus, and I have that. So I have to think about handling those. Let's see. Up here, it just divided straight out, so I'm going to look for that again. A 7, it looks like. So I think it's just going to be a positive 7. If I get a 5x and then be a minus 2, good, it works. See, our two polynomials here match. And so now I can go ahead and put it all together for my final answer. And this should match yours. 5x minus 2 times 2x plus 7. There we go. All right. So today we talked about how to solve a problem when your a term is not 1. And I'm going to stop sharing my screen now. There we go. So good luck with that. Give it a shot on the homework. Try it out. Just take your time. It requires some erasing sometimes, and you can always run a check at the end if you need to. But it's nice that that check is built in as you're going, so you can tell if you're on the right track. And if you get stuck, if you need any help, just let me know. All right, I'll see you next time. Bye. Hi, everyone. Good to see you again. This lesson is designed to match the factoring lesson when factoring when a does not equal to 1. It's a nice complement, a supplement really, to go along with something that you just learned. Let me go ahead and share a second little bit of notes with you. Okay. So with this, we are going to title it something new. Just trying to struggling with that a little bit, but I think it's better if we do. We're going to say factoring when a does not equal one, and you have a common factor. Hopefully, you've already learned how to factor when a doesn't equal one. It's a many-step process that works every time, but it does get a little confusing as you go. However, there is sometimes a simpler way to do it, and that's what I'm going to talk about right now. The thing is, with the simpler way, it does not work every time. And that's why I wanted to teach it to you after you learned the other one, is this one only works sometimes. But it's important to try it actually because it could save you a lot of work. So let me give you an example. Uh, let's say we had 4x squared plus 24x plus 20. So you already learned how to factor these. We could multiply the a and the c term and find the b and all that good stuff. However, when it's set up like this, there's actually a special thing going on here. And this is how you want to start every factoring problem when a does not equal 1, is you want to look at each of the coefficients and ask yourself, is there some number that divides evenly into all of these? And I notice I can divide them all by 2. Actually, I can divide them all by 4. It's really important you find the largest number you can divide them by. So watch what happens when I divide by 4. If I take out a 4 out of all of this, then I'd have x squared plus 6x plus 5. And now, if I stop and I ask myself a minute, wait a minute, can I factor this in here? You absolutely can, because my a factor, my a term is now 1. So I really don't have this situation going on. All I had to do is divide out the common factor, and now I can go through my normal factoring process. And so I just have to make sure I leave this 4 along with the problem. And so I'm asking myself, what are the factors of 5 that make 6? Let's see, that'd probably be 1 times 5, right? Those would add and make 6. So there's only one way to make x squared. That's x and x. All these are positives. So it doesn't matter which one goes first. I'll put the 1 there and the 5 there. And there is my answer. Isn't that so much better than having to go through that long process that you learned about? Like I said, this doesn't work every time. It only works when you divide out a common number right from the beginning. Okay, let's try another one. Let's say you had 3x squared minus 45x plus 168. So again, before I start, I ask myself to divide all of these by 3 maybe to get rid of that term. I can divide 45 by 3. Does 168 get divided by 3? Let me check. If it doesn't, then I have to go through that other process that takes a little bit longer. Oh, but it does. Cool. So I'm going to take out the 3, and we get x squared. This would be minus, what would that be, 15x. And then this would be 56. And now I just have to go through my normal factoring. So I know I'm going to have the 3 out there, and I'm going to create something in here. I know they're going to be x's. And now I'm thinking of the factors of 56. It'd be like 1 and 56, but they need to add to make negative 15. So let's see, that doesn't work. What if it was like negative 2? What would that be? 28. No, and actually I'm thinking this larger number maybe needs to be negative. Does 56 get divided by 3? No. 56 divided by 4? Yeah. Let's see if it was 4. It'd be like that. That doesn't work. 5, 6. I don't think 6 is gonna work. Nope. What about 7? Like there's having a problem. Ooh, yes, 7 does work. Ooh, and actually, wait a minute. This has to be positive and that has to be negative. So both of these have to be negative. So I was actually looking at that incorrectly. Negative 7 times negative 8 would give me 56. And if I add them, I get negative 15. So I'm going to use x minus 7 and x minus 8. There is my answer. Okay, go ahead and try this one on your own. And you'll pause the video and look at the answer once you're done. Here's your problem. You're going to have 2x squared minus 2x minus 18. Go ahead to pause the video now and give that a try. All right, here we go. We're going to look at the answer. I can divide out at 2. So I get x squared minus x minus 9. And now I'm going to leave the 2 there and factor this. I know these are going to be x's, and I need the factors of -9 that add to -1. So would that be -8 and positive, no, wait, -8, what am I thinking? -9 and +1, nope. Maybe like a 4 and a 5, but then maybe the 5 would be negative. There we go. So this would be minus, or we can put the 4 first, +4 minus 5, but the order doesn't matter. There you go. All right, good luck on your homework today. Bye, everybody.